In the previous video, I talked about two ways of building smart contracts visually, by data flows and state machines. And I also showed you a first example of a smart contract built visually with a state machine editor. Today you will see an entire ERC20 contract built in the same way as a finite state machine. As mentioned in the previous video, we are using the stately visual editor to create our state machine. And then we will interpret and execute the resulting JSON, which can be found here. This JSON object is the configuration of the state machine, and we will execute this in an interpreter that I built that functions like a WebAssembly smart contract on our Mythos chain. Now let me explain this diagram. So for this, we will go into simulate mode. Once this state machine is created, the ERC20 token is automatically initialized, and its state will be unlocked. Actually, the state will be the first state under the unlocked state, which is active. In addition to the ERC20 functionality, in this example, I've also added ownership and the possibility to lock and unlock operations in the contract. And you can visualize this in a beautiful and clear way in the state machine. So when the contract is locked, the only possible transition is unlocking the contract. And when the contract is unlocked, we have access to all of these functions like transfer, mint, approve, transfer from, and lock. So here I added a mint transition, so we can easily get some tokens as the administrator of this contract. The mint event will trigger the mint action only if the caller is the administrator, is the admin. And this is a self-transition, so we get back to the active state once the transition is done. Once we have the tokens, we can send the transfer event, which sets the current ERC20 state to in transfer. So if we click on transfer, we get to this new state. More specifically, the state will be unmoved, which is the first state under the in transfer state. So our interpreter already supports nested states. Now in the transfer event, we see the raise function, the raise action. So what happens is once the transition to the unmoved state happens, we will raise the move event, which then triggers the move action that will actually move our ERC20 token, the log transfer function, which logs the transfer from two addresses and the amount. And then when this transition is finalized into the moved state, it will also automatically raise the finish event, which will get us back to the active state. And at this point, we are ready for the next transition. And we can also call the approve function, which is also a self-transition. And with this, we approve allowances for other accounts to transfer tokens through the transfer from function. And the transfer from function has the has enough allowance guard. And if this passes, again, we go through the in transfer state and through this child process. Now, this mechanism of defining a state for when the asset is moved can be used to avoid reentrancy issues. If instead of an internal asset move like we have here, we would have a cross-contract call as long as we save the current state of the state machine to storage before the cross-contract call is made. Then that cross-contract call cannot trigger a reentrancy attack because it would find this ERC20 token in a state, for example, the unmoved state, in which it cannot perform externally exposed functionality. So when it is in an unmoved state, it cannot mint or transfer from. So you can make a general mechanism for moving assets regardless if the assets are in the same contract or in another contract, and have this mechanism be secure and clear. And now the actual demo of this state machine working. So now we are going to copy this configuration from stately until here. So we are not copying the types and action definitions. We are going to copy the state machine configuration here. We need to transform this so it can be parsed by the JSON AS package for AssemblyScript. So we are going to run the script here and then copy this modified configuration. Now here we have our UI for interacting with our local Mythos chain, which is running here. And I've already deployed the state machine interpreter. I've uploaded the WasmX file and then instantiated the contract that was given a code ID of 21, and we have the address of the state machine interpreter contract here. So what we are going to do now is create a new state machine. So we will call the create function with the configuration that we've just made. And this is a state changing transaction. We are going to run it now. And we have our transaction receipt. We'll get this transaction hash, search for the transaction, and look at the data that was returned after execution. And we'll decode this data so we see that the ID of our machine is 0. So this is what we are going to use when interacting with the machine and reading state from the machine's context. And we can see the current state of this machine is active. So we are now in this active state where we can interact with the ERC20 contract functions. So let's mint some tokens. So we will apply the mint event to the machine with ID 0 and the parameters to and amount. So we want to mint 100 tokens to our own address, and we will copy this address, we'll transform it to hex, and then what we need to do is pad this address to 32 bytes. So this is the value that we are using here. And after this transaction is done, we can see our balance by looking into the state machine context. So we don't yet have state reading functions from ERC20 like get balance of. We are reading directly from the state machine context. So let's get again our address here, and we have 100 tokens. So let's do a transfer of tokens. And I already have a receiver address prepared here. And we will check the balance first. And the balance is 0. We don't have anything there. So we will run the transfer event to our receiver address, and we will send it 10 tokens. We run the transaction, and we can also take this transaction hash and look for the transaction in our local explorer. And if you remember the schema here that we had in stately, we should also find a transfer log. So right now we are in the transfer transition, and we should see the asset moved and a log made. So if we look at the transaction receipt, we can see a WasmX log. So this is the transfer event, and we've logged the state machine ID, which is 0, then the from and to addresses, and then the amount, which was 10. So now we can look again at the balances. So let's see our receiver balance. It should be 10, and it is 10. And then let's look again at our initial admin balance, and it should be 90, and it is 90. And of course this state transition has finished, and we are again in active state. So we can try the approve transition. So for this we are approving a spender. So let's load another account here that we have, copy the address, go back again to our admin to make the transaction, and pad this address like we did our admin address. And this is our spender. We are executing this as a transaction, and then again we can look in the context of our state machine to see that the allowance for this address is actually 10. So I'll copy this address. It's an allowance from our admin account to our spender address. And we have our value of 10. So now we can switch to the other account that is our spender and run the transfer from. We are using the same receiver address as for the first transfer, so we are transferring another 10 tokens, and we need to add here the account from which we are transferring the tokens, which is the admin account. But we are executing this transaction from the spender account, which has an allowance. So we are going to execute. And again, we can look at this transaction hash and see that it has a log of our transfer from this address to this address, and we are transferring 10 tokens. So again, we can query the balance. Let's query our recipient balance first. And it is 20 because we've had 2 transfers of 10 tokens. And our admin address should have 80 tokens left. And we have 80 tokens. So you have seen an ERC20 contract implemented as a state machine. The current state machine interpreter prototype can be improved by using BigInt, and I already have a library for AssemblyScript for BigInt. Right now, the state machine can only store strings, so this can be improved by having typed storage for addresses, BigInt numbers, strings, and so on. And then we can have a collection of general functions that can be used by most state machines. And finally, storage. Right now, we store this state machine configuration objects and their state context in the same contract. But you can create a new contract address or namespace for each state machine and use it for storing state, while keeping the state machine immutable definition in the state machine interpreter contract. And like we have done with other interpreters, this contract can be elevated to a core meta contract part of the system. So creating a machine will be just like deploying a smart contract. If you want to help the Mythos project by becoming a validator and testing the system, you can join our Discord.